Now we need something to run against, because everything is good except for this thing right here. We still have no URL. We have no server, which of course is the whole point of this, because it's the right one, right? Tester development, write the test, and then make it pass. So we're in the make it pass phase. Seems like you guys got all your questions out, but just in case, we're about to shift from testing into a different era, or different, whatever, not era, different something. Main source. We're going from test to main source. So are there any other questions related to tests or anything that's not clear about what I've expressed here? Okay, good. So we have a couple of options for how to run a Jersey test, a Jersey server, Jersey API for this test. The one I'm going to use here, because it's very convenient, is the Jersey test framework. I mentioned this earlier. It's just with Jersey. It's not part of the JAX-RS API standard, but it's only a component of Jersey, but it's very handy for standing up Jersey service for testing. It has several different options for running testing services, including numerous different containers you can deploy them into. By the way, like serverless containers like Grizzly or Jetty or I think it's worth Tomcat. You can even run like an in-memory glass session and other stuff like that. You can also mount a Jersey web service in memory where it doesn't actually make HTTP calls. It just binds client calls directly to the Java method call, which is kind of cool. Because it still tests everything, but it goes much faster without the HTTP interaction. Of course, I didn't do that because obviously that would work still. Even the way I wrote it, it should all work because the responses and everything is generated the same way. But we're not going to do that here. I select by the dependencies that I pulled in, I selected the test server that I was going to use, which here I said I wanted the Grizzly 2 test framework. So that means that when we fire this thing up, it's going to be running stuff in the Grizzly serverless container, which is the reference serverless container built into Glassfish. Now, the idiomatic way of using the Jersey test framework is to extend the class called Jersey test. Being Spock, we have to extend specification. In Java, we're trapped by single inheritance. Fortunately, Jersey test works well enough standalone, and it's only slightly messier. We can essentially use aggregation over inheritance by saying Jersey test equals test. There. These things are necessary because this is actually an abstract class. It has no abstract methods, but it's an abstract class because the Jersey guys assume that you would always be extending that assumption. We can tell it to look for our RESTful service classes in that package. Now, since we're not extending Jersey test, we're going to have to invoke the lifecycle methods ourselves. Also notice I made this a shared resource. This is something that you definitely want to be shared. Otherwise, it's going to be starting up and shutting down a server for every test. And in fact, that's when you extend it, like a normal, if you extend Jersey test using the idiomatic pattern, that's what you get out of the box. And it's a real pain. Maybe they fixed that in a new version. I haven't looked into the newer versions of the Jersey test framework, but it's something to watch out for because your startup time can get pretty long. So given that it's a shared resource, we don't just use setup, we use setup spec, which is equivalent to a JUnit for class. We say Jersey test setup, and then honestly, I traveled too far today. I can't say the right word. Wrong words going out of my mouth. Cleanup spec. Metrically is the word I was looking for. Cleanup spec, we want to Jersey test. No, that's not using that. Jersey test tear down. Okay. Now, Finally, Jersey test, after you get it all set up and everything, it provides a web resource, which is what this guy is, for you to talk to the container that's running the test. You don't have to know what container it is. You don't have to know about the base URL. You don't have to know anything. All you have to do is say, test resource. And like magic, it works. Whoa. That's very interesting. I haven't seen that behavior yet. Breathing Blind 9. I should have warned you guys about this ahead of time. I'm using an early access version of IntelliJ 12. And those aren't always the most stable. It's still better than I do have the stable version of 11 installed in case I need to fall back. Looks like we're happening. Now this should, let me make sure I'm up to date on my notes. Yeah, this should work. Operative working should. I think that I have stumbled onto some kind of bug, either in Spock or in Groovy, because this is supposed to be the list of packages for it to scan for RESTful resource classes and stuff, and I'll show you. You'll see examples of those in a minute. But for some reason, this gets interpreted as a list of 7 packages: package C, package O, package M, and so on. And I worked on this for a couple of hours, and I could not figure out what was going on. All I could figure out was I can work around it like that. Tell it explicitly that it is a string array, and it's happened. So that one minor change, and we should be ready to go. Let's run this. All right, so we got some failures as expected. You notice persevere right here says the resource config instance does not contain any root resource classes. Root resource classes are what JAX-RS and therefore Jersey call the class that is an API, provides an API. This class is where it's like a root entry point into your web server, and is correctly observing that we do not have one of those. So we go create one. Back to main source. Pure Java again. Getting out of Groovy land now, and we're going to create a user API. Now, this is a class. And now it is a resource. So it is a resource class. Resource class is anything that has a path on it, pretty much. And that says that this is a RESTful web service that is rooted at the path users. So if we go back and we remember the identifiers we were talking about, that means anytime you send a request here, it's going to get handled by this guy. Or down in here, or further down. Anything rooted in users is going to go here. Kind of like servlet mapping, right? Just no XML, all annotations, all Java. So if we run the test again, which is just slightly different outcome. Not quite so much red. Hooray! We got past the test. Because operations on non-existent users should return not found. And there are no methods, so nothing's found. They'll start failing soon, I promise. So our first real failure, though, is here on our create. Users can be created. Condition not satisfied. Expected at 201. Text is supposed to be bigger. You guys read that okay? Okay. Expected at 201, but wasn't 405. 405 in HTTP/REST means method not allowed. It says you're not allowed to post to this URI. So let's start implementing. Take a look at what our test is. users can be created that says, well, I guess I better go down here. Create. Here's our path, users. We got to send a user in the content, in the body. We're going to send it as JSON, so a valid representation at least should be JSON. And it's going to be a post. And then when we come back, the response should be a 201, and it needs to contain the location of the just created user. Let's go make all that happen, a little bit at a time. First, we need a post. Okay, post. Easy. Has to be applied to some method. So we'll do that. Now, technically, we now have a method that accepts posts. So we would no longer get a 405. We'd get some other failure because the create's not actually happening. I'm not going to run through this at that level of detail, so we can get through all this because we don't want to drag all this out.